All right, so Colin, we are not 100% sure if you're here or not. So, no, he does exist. Because remember, matter cannot be destroyed. So, you even exist once you cease to exist. That's separate for a moment. All right. What?
Wait, I
What do
see.
you mean?
That's a contradiction in terms.
Yes.
I exist when I cease. That's not possible. Huh?
We're not going to talk about this right now. We're not going to
Just
get
die.
All right. Things that we can prove, unlike existing after existing. So, triangle mid-segment theorem is one that we are pretty familiar with. Gentlemen, am I going to have to actually take calculators? So, we want to actually make a proof of this. So, we are going to help Sergio. So, Sergio wants to explore the triangle mid-segment theorem, and he wants to know if he can use similar triangles to prove some things. So, we know the triangle mid-segment theorem gives us similar triangles. At least we should know that. And if we're in the mid-segment, we should know something about those similar triangles. I will let you and your groups discuss that. So, B is going to ask us to write a conjecture about the relationship between DE and AB. And then prove how we know this. So I'm going to give you guys a couple minutes. What do we need to list out to be able to use to show that these triangles are similar, and then prove the relationship between DE and AB that shows that AB is twice of DE. So our end target goal is that proof statement there. Questions? Let's two-column this thing. I'd like for us to have homework time at the end, so that's why I'm just kind of diving straight into things. So what do we need to list out? What shares between the two triangles? What theorems do we need to reference? How do we prove that?
That's why it's all laid out right in front of you, and then they're just like, okay, tell me why.
Okay. So what would be the first thing that you'd state?
Well, then we have to prove that
You don't know that.
Yes, I do.
CE is double CB.
Look at it. all the side lengths are half of the big one. So
Hey, Gunnar, maybe you can do some proof. You can be the explaining.
I'll be the angry black one.
Okay. Angle C equals angle C. Love it.
The reflexive property and given, I guess. Whether we consider given or we can make a statement for it.
No, wait. Ryan, side angle side proves congruence.
There's angle similarity.
Ooh, angle similarity.
I think it's really the only similarity here.
How can we prove angle similarity here? Okay. Well, two different sets of angles.
Well, if you find that they're similar, well, you are forgetting how to word this.
What? So I'm not going to make us write out the whole two-column thing, because as Gunner's getting very frustrated, I'm getting scared. So let's discuss this, okay? Gentlemen, can we put the calculator down? I know it's not necessary right now. I'm fairly certain we're just goofing. Which is okay at certain times, but we need to have this conversation. What would be the reasoning if I try to prove those angles congruent? Yeah. Parallel lines and what sort of angle? Corresponding, right? Now, we know that D is the midpoint of CA and E is the midpoint by definition of midpoints, right? So, if we are going to state that those are corresponding, we would first state that DE is parallel to AB by definition of midpoint. Then we can state the angle's congruent. Then we can prove the triangles are similar. And what do we know about similar triangles? Yes, but be careful. Constant ratio. Then, like Gunner's arguing, it's right in front of us. We could say that CA is what? twice as much as CD, and that's actually given, like we just see that. Or definition of midpoint, right? If D is the midpoint of CA, then CA is twice of CD. Then we could say AB is twice of DE. Right, so that corresponding parts of similar triangles, I forget exactly how they say it in here. I really don't know what to do. Yeah, let me read these. Look at 57. Go ahead and check out 57. Hey, we know what we need to do. We can do it on our own, right? Nice. We know we can do it on our own, right? I'm just finishing my drill, sorry, I'm slow right now. You're not drawing, are you? Imagine being the person with the class.
Yes, they are.
ABC is not similar to ABD.
Yes, it is.
No, it's not. ABC does not have a ABC. Oh wait, that is wait a minute. Oh, never mind. I am dumb. I am dumb.
So this is a really fun proof. So I'm going to give you guys a little bit of time with this. This is a really fun proof, actually.
Wait.
Now, take A seriously. The order in which you name your triangles is going to be really critical here. I would order them short, medium, like maybe I should. If this were me, to make my life easy, I would start with an order that I choose and make every triangle fit that. So if I say triangle BDA, I've gone in order, the short side, then the medium side, and my hypotenuse would be from the last to the first point. So if I go BDA, that has gone from short up to medium. So then if I relate that to another triangle in the diagram, that order should go short through medium. So if I go this, the medium triangle, I will go short to medium. So A, D, C. Likewise, the third triangle that we see here is the entire thing, short, medium. This is where people get screwed up. What's the medium leg of my big triangle? AC. This is my hypotenuse. Remember that. So I go BAC for that triangle. If you want to use that order. Wow. Even worse than what I would make.
ABC is similar to that.
It is.
So the big question we approach first is why are they similar? How can we prove those three triangles similar to each other?
So confusing because there are three different triangles that you have to look at the same time, and then they're all just.
So maybe on your paper separate them.
That's a good idea. Do that.
Draw one together and then one separate.
Are you getting a ruler, Chris?
No.
A protractor? Tracy
So
did that.
if we could have one is similar to the other, and one of them is similar to another.
They all line up.
We use a transfer property.
Yeah.
Similar to that, then
Fixing paper again.
But do you think
Why not?
If we just theorems prove those two, is
That
similar
would
to
just
the
leave
AC.
them all up.
So, yay!
Hmm.
Wait, there's so many ABs.
Can I prove triangle BAD, or not triangle, angle BAD is congruent to anything else in here?
Oh.
Well, if these triangles are similar, then there have to be congruent angles. So that's what A's asking us, right? Why are all they similar? Why are all of them?
Oh, because, yes.
Ryan?
Actually, you can prove it congruent to C and D.
Why?
Because of what's the word?
Don't say corresponding. We don't have parallel lines here.
Congruent angles.
Take a moment.
Oh, I see it.
Take a moment. Let this simmer for yourself. We can prove this.
Because
Talk with your partner. How do we prove
the
this?
other part of A has to
What relationship exists up here?
and this has to be this.
Those two angles, those adjacent angles. Ryan, help me out because you're going too fast for them. What relationship exists up here?
I forget the word.
Complementary.
Complementary. Now you didn't have me for 7th grade. To complement someone is the right thing to do. They make a right angle. I will never stop it. So this angle is complementary with my blue angle right there.
Yeah.
What other angle has to be complementary with it? Because your hand went back down. I want to get.
Oh.
Ava?
B.
Angle B. Because triangle sum theorem.
Oh. Oh.
If we know that blue, red, and 90 have to make a triangle, they have to make 180. We also know that these have to make 90 because it's given to us, right? That's a right angle. So we now see those pairs, and because this is 90,
That has to be 90, so then you get C.
those have to be complementary to each other, and we have found congruent angles. By angle similarity, we've got similar triangles.
Got two similar triangles.
3 actually.
Well, how do we find the third? I only see one. I don't see how to prove the third one. Like, I see how you prove two.
What angles do my
Oh.
little triangle
Oh,
use?
never mind. I see it. Okay, thanks.
Blue, red, 90.
Yeah.
Blue, red, 90. Blue, red,
The red and
90.
blue complement to make an angle. Okay. Sorry, it's just like.
That angle right there does not look like a 90-degree angle.
It's because how it's positioned. So, Carol then argues those ratios. Do we agree with what she has set up?
Yes.
Well, I agree with the first one.
So what is DB over AB? DB is short side, AB is hypotenuse.
No. Yeah.
DB short to, if we're looking little triangle, we've got short to hypotenuse. Is AB short and CB? Okay, short to hypotenuse, so that works out. DC to AC. Okay, medium to hypotenuse, I think. If it's using DC, it's not the big triangle, right? It's the medium triangle. DC to AC. So medium to hypotenuse. AC, medium BC, medium to hypotenuse. Is that ratio right?
Yeah.
Okay. So she's just relating those sides. Let's see. How can we relate that AB squared is actually CB times DB? Or AC squared, take a moment, is BC times DC? This is not a scratch, actually.
Give a value. Give it a value.
I need highlighters.
27 squared.
27. I think that.
Anybody else? We agree with those ratios, yes?
Oh, because of proportional. Because they're proportional. So if you just cross multiply, then BC times BC equals AC squared.
Oh.
I see it.
AB squared,
Oh.
AB times AB,
Oh wow.
Wow.
DB CB.
Uh-oh.
AC squared,
Uh,
BC BC.
wow.
Because we agree with those ratios, right? Those similar triangles create consistent ratios. They're proportional. We use proportions and can cross multiply, and we get those statements. But what good does that do for us?
Well, we can go from there. Well, that's the.
What is AB? So if we're going to look at AB and AC. AB and AC, right? Because that's what they use, right?
Yeah.
AC, AB. What triangle are we looking at?
We're looking at the smallest one, the biggest one.
Well, so AB's there, right? AC here, if we're going to look at both of them at the same time, what triangle uses both of those at the same time? Big one, right? The entire one that we're working on.
They're the two legs. Aren't they the two legs? And then BC is the hypotenuse of the big triangle. So
Let's make sure everyone heard what Owen just said.
They're the two legs of the big right triangle. Yeah.
The only thing we haven't looked at, well, not only thing, but what we haven't looked at right here is this, and that's the hypotenuse of the big right triangle here. So what we have are legs squared, legs squared. So if we know that AB squared is equal to CBDB, and AC squared is equal to BCDC, hard to say, we substitute, or sub in. But why? Why does that matter? What do we then do from D to E? Take a moment. What do we then do from D to E?
Oh, there's so many letters.
Take a moment. Write it down if you want to. Go ahead, would you please write down from here down, because we should work that. So write down that AB squared is CBDB, and AC squared is BCDC. And what we're really looking at then is what plus what. I'm going to jump past all this so I can write. AB and AC? Or two legs, right? Leg one and leg two. So really that AB squared and AC squared is setting up your Pythagorean. Right? Leg squared plus leg squared. We sub in CB dV. How do they get this? Because that's actually, if you have space on your paper, that's an extension of this. They essentially say, well, this equals, because CB, dV, BC, DC, this and this are the same thing, right? Please notice that. If you can on your notes, just keep extending right, and you can write this. How do they get that, though? What? Did you say divide by A?
Well, A is not there anymore.
Your face is going to have to meet your palm if I tell you that.
That's not good.
Don't tell us.
What would you do if you were presented with something like this? What would your initial thought be to do? Distribute.
Oil.
What is undistributing?
Oh.
Oh, this is
So.
So it is.
Yeah, we're good.
That's fine. Yeah, that's
BC and CB are the same thing.
so. Divide by
Are you sure?
Yes.
I can't tell if Jenny's unamused or if you're angry.
She's grouchy.
I just I didn't notice that before. I should have seen that.
Anytime we can make things simpler, right? If I can factor out a common term, that will probably make things simpler for me. So please, on your paper,
I mean, I saw that. I just didn't know that,
Didn't realize.
yeah, I saw the two things and I was like, wait, why are they,
okay, so that equals our fact. Okay. BC times dV plus dC. Now I want you to take a minute and look at what this is. BC times BD plus DC.
whoa, it's just,
Keep it to yourself for a moment. I hate. Well, it thinks I did it, and I was like, oh no, don't do it that far. What is BD plus DC?
Just you just multiply.
B squared. Squared. Oh, we just proved something. Whoa.
Oh wow.
Why?
Whoa.
The
Okay.
hypotenuse.
Did we just
Add it up.
That's Pythagorean theorem. That's it.
Right.
That's the
Did
proof.
your mic break?
Hmm?
Did your mic break?
Yeah, I dropped it.
Hey, that's not good. Yeah, but
It's a fictional mic.
I dropped my phone.
Guys,
I grabbed my module that
Take a moment and just look so all we did was start with 3 triangles. Right, I want you to take a moment to see how I want to say beautiful, but I know you'll roll your eyes, but this is beautiful. All we did was start with a right triangle. You could have started with 1 right triangle and made this happen. Because then we drop a line that creates 3 right triangles. We actually just drop an altitude from the from the hypotenuse angle. So if you drop an altitude onto the hypotenuse, you then have created two right triangles inside your right triangle. Pretty cool, but nothing that important. We then quickly and easily, using triangle sum theorem, we're able to prove that those triangles are all similar to each other, which is pretty cool in itself, that altitude makes similar triangles. Then we were able to piece it all together that these corresponding parts can be substituted in. We can play with the math a little bit and prove the Pythagorean theorem in like less than 5 minutes. Because this took people years and years and years to get to
Well, I
these
don't
points.
doubt it.
So when you guys are like, oh, I hate proofs. Proofs are how mathematicians were able to defend. So like, just take a minute to conceptualize this, right? So
I should just color coded it.
So-
Color code is so much easier to work with.
Pythagoras, that kind of gives it away some crazy.
And-
Pythagoras wanted to make some declaration of mathematics. And in order to do that, you have to back it up with evidence. So if he walks out the street and he's like, look guys, I've made a theorem and I've named it after myself. I can prove for the hypotenuse. People would be like, nope, wrong, and try to disprove it. You put this in front of them, say, look, all of this holds up mathematically. It all justifies back to statements and reasons that cannot be disproven. I have the evidence right here in front of me. And nobody could say anything about it. That's still how mathematics works. There's a boatload of problems that are worth $1 million. But if you want the $1 million, you got to prove that your answer works.
But that's what the mathematicians got the $3 million for, right? They discovered that something might be true.
Yeah.
What was the equation?
It wasn't like an equation, it was like, there might be other dimensions and crap.
It was. I had the article posted on Schoology. If you want to check it out, I think I named it like $1 million for each of them or something.
Oh yeah,
Let's solve it.
All right.
let's
keep moving on.
Yeah.
It was like.
To get to any point where you want any shot at solving those $1 million problems, this is your foundation, right? So Sophia lays a coordinate grid over an astronomical map. So she's a star nerd. Sophia notices that star A is located at -4, -2, and star B is at 8, 4. There is another star at the midpoint between the stars. Where is it? And then, how far is that star
Oh, this is like one of the questions in the math
of
conference.
the other stars?
That one with the distance to the one
The
third.
same.
Line.
That was interesting.
Ooh.
So I solved that $1 million.
Ready? I'm gonna solve it. What is halfway between Chinese and B?
So, Chris, the extension piece happens in B. You get it, you can find the midpoint, but extend that to other locations.
X plus X. Wait, was it X minus X?
Or let's do graph this.
Oh, that's complicated.
Can if you want, sure.
Solid.
I'll never say no to graph.
What?
Normally,
Two.
one. Oh no.
Oh no.
Oh, that's
44 plus 6. This is my last piece of graph paper. Whoa, get the more.
So let's see this one thing.
Left hand.
Yeah, of course. Okay. 1/3. 1/3 of the way from A to B, so it's closer to A. Okay.
How'd you do that? Did you all mental already?
I'm surprised no one's asked the question yet. We are assuming that the asteroid is traveling from A to B. Now, it says 1/3 of the way from star A to B and 3/4 of the way, so you can make that assumption. But if you want to think about it in astronomy terms, assume that something has escaped the gravitational hold of star A, and the closest gravitational pull is star B, hence why it's traveling from A to B. It was in orbit and escapes and heads to B, and we'll get stuck in B's orbit for who knows how long. I'm very hopeful that we can all get midpoints at this point in our life, if no other way than just averaging both your x's and your y's. So, what is the midpoint of star A and B, where the asteroid is in A? Yeah.
2, 1.
Agree? Disagree? Good? Then the distance between star A and the asteroid, or the asteroid and star B, and a trick that you could use to do this, that in previous years we've taught in a different way. If you know that this distance is the midpoint on the hypotenuse, you could calculate the hypotenuse and do half of it if you wanted, or you can just go ahead and calculate the distance between those 2 points. Depends on what's easier for you. Either way, what do you get for that distance? Don't think it's a perfect, right? Doesn't it stay in radical form? Yeah, and you can approximate. Did you approximate it or what?
But I didn't see that part.
Check that again.
Wait, yeah, it says plot the points on the graph. I didn't see that until now, but I
Are you using these 2 points? Because we're doing distance between here and here, or here and here.
That makes
Now,
a lot more sense.
hold up. So, if you want to use that, you'd have to cut it in half. So you have to look at the rational
Well,
form
that's
before
what I
you
did,
cut it
and
in
then
half.
I did 7.2. I think that's still wrong, but you know, it's still good.
Should be radical 45. So if you cannot get to there, please raise a hand. We will solve that out together.
I think I might have. Let me redo it because I think I might have said something wrong.
So if I do the work, it's okay. You can redo the work while I do it. My x change from -4 to 2 is 6. So I can make A 6. B, my y change is 3. 6 squared is going to be 36. Plus b squared is going to be 9. We get 45,
Oh, you did the hypotenuse thing. Okay.
which means my distance is radical 45.
You could simplify that more to be 3 times
About 6.7. Oh yeah, you could simplify into rad form still.
3 times radical 5.
It's actually 6.7082039.
Already looks good. Right eye is the slowly color. Wait a minute. Number 3, I mean.
Yeah, you just realized that.
Oh, okay, got it.
It's trickery. I found the distance from star A to star B to 130. Draw it out and then.
So it's not asking distance, it's not asking the location.
Okay, so I is 1/3 from A to B, right?
Oh,
So if you go around the
If we drew this in triangles, or like on a grid, now let's say we make a new -4, -2, somewhere like here, right? Especially if I go with a numberless graph. And then +8, +4, way out here.
Oh.
If we make this a triangle, How can we use similar triangles to help with what we're trying to do?
Oh, we're going down.
Sorry, what did you say, Gunnar?
12, 6.
Draw the line.
You're right, yeah.
You can do 12 and 6 to mark out what it is now and then multiply it by 1/3. But we want coordinates. Yeah. Right? I always have to do
What do you mean 12 and 6? Oh!
6.
So here you're doing, or sorry, here you're doing 12.
Yeah.
Here you're saying 6.
That's what I did.
And if it's a third of the distance from A to B, then this will be where? And then if it's half the distance, you could do that here. The 1 and 3 are the same, if you didn't catch that.
Yeah.
2/3 from B to A.
Yeah. I caught that.
But what about part 4 here? Any ratio of the distance.
That times the distance. Let's just say D.
What if my ratio is 1? Like the entire thing. What happens to your x as I get that ratio? What do I do with my x? So the ratio was go all the way. What happens to the x?
Always multiply it by point B.
Point B? What?
Wait, no, never mind. The x is point B. Oh, no. Never mind.
Wait,
Ignore
if
that.
it's 1, won't it just stay the same?
Yeah.
Oh, so x minus.
Oh, so wait. So that would be
Close, careful. You're looking at the y.
So it'd be the x times 8 because that's the x value of point B, where we're going to in this case, right?
So if my x goes the entire distance, my comet goes the whole way, or asteroid, or whatever it says, then my x goes 12, right? Goes all. So really, my -4 adds 12, but we're not going the whole distance of 12.
Wait, is it x
X times 12.
and y
Close.
x
Think about this for a second. I'm not going to get
The
it
x is always on the bottom. Rise to the right.
close enough. 100%.
You guys already told me that when we go all the way, we go 12, we go 6. What if I go half of the way? Half. Well, what happens to the x? How far would the x go if I go half the way?
It would go 6.
It'd go 6. How far would the y go?
It would go 3.
How'd you figure that out?
Because that's half of 12.
Okay, so what if I go a third? What if I go a third of the way from A to B?
Yeah, that would be right.
So what if I go DC of the way?
Wait,
DC.
is it
C.
12
D over C.
D over 12 and C over 6.
D over C times
12 over
12.
D and 6 over
Your
C.
dilation factor, essentially, is what we're looking at. Times the entire change.
Oh.
Hey, that's close enough.
Yeah.
It's whatever portion of the distance times the entire distance. Or we know the whole distance is 12, so I go half the way, it's half 12. Third of the way, it's a third of 12. Fourth of the way, it's a fourth of 12. You can do each of those individually, but as soon as I make it just variables, you guys get hung up. You were very quick to answer half, third, fourth, like. But think about it. If it's D over C, it doesn't matter. It's just like any other fraction. Multiply your fraction by the distance you know you're going. Have that effect on the original. All right, you have like 3 or 4 minutes that you can work on homework. Sorry we didn't have much time today.
No.